Hello, and welcome to today's video tutorial on Patton gateways. Following on from our on-premise PBX setup, and due to popular demand, we are covering setting up Trinity-based Patton gateways to a 3.6 system in the cloud. For this, I will be utilizing a VPN tunnel to make the connection to the hosted system. Using an FXS gateway, this will enable analog endpoints such as phones and fax machines to take advantage of the wide range of features provided by our VoIP phone system. First of all, let's talk about Patton. Patton are a provider of electronic products. In this video, we are going to concentrate on their VoIP gateway range, which are used to translate legacy telephony technologies to IP. They offer gateways to integrate IP to analog FXS devices, such as legacy handsets and fax machines, FXO lines, and ISDN, BRI, PRI services. Patton devices running the Trinity operating system will soon be replacing the popular SmartWire range of gateways supported by 3CX phone system. In this video, we will be exploring the reasons for the change, the benefits of Trinity products, as well as showing a live demonstration of auto-provisioning and setting up of a Trinity-based gateway with 3CX in the same method as a SmartWire-based device. Patton and 3CX have had a strategic partnership since 2013, of which their gateways have been fully supported with the PBX system. 3CX phone system includes a configuration tool with built-in configurations for all SmartWire models, as well as step-by-step guides on how to use the tool. For Trinity-based products going forward, this has slightly changed, in that Patton will now take responsibility for the writing and providing of templates for 3CX partners wishing to use Trinity-based devices with 3CX phone system. 3CX supports three main setup methods to the cloud: VPN, the 3CX Session Border Controller, and Remote Stun. Only one of these three setups are feasible and supported by 3CX for remote PSTN gateways, and that is the VPN method. To start, let's cover what VPNs are and why they are a popular choice for connecting our gateway to the cloud. VPNs, or Virtual Private Networks, are a networking configuration normally between two locations which create a safe and encrypted connection over a less secure network, such as the public internet. VPNs extend a private network across a public network and enable users to send and receive data across a shared or public network, as if the computing devices were directly connected to the private network. The VPN setup method with our 3CX system is just as stated, an extension of the network. Our VPN connection in this tutorial will be an IPsec VPN setup. IPsec is a common standard that offers protocols for cryptographically securing communications at the IP packet layer. It is also important to note that for the VPN setup, you require two firewalls to achieve this. One on the local site, as seen here, and in our example, one on the edge of the virtual server, in this case being a software firewall with VPN support, such as ones provided by pfSense. As seen in the previous video here, we can easily set up a Patton Trinity gateway to 3CX locally. This time, however, we are going to connect the device to a hosted cloud 3CX system via a VPN. The VPN method is fully supported. However, there are some things that need to be considered on a networking level to provide us with success. Firstly, our IP subnets. Our VPN is connected over a VPN tunnel. The PBX platform can see the local site and simply sees it as just another local user in another subnet. Devices are accessible and pingable from the cloud platform. In our example here, the 3CX platform is in the local subnet 192.168.251.x with a Class C subnet, and our local site, including the Patton gateway, is on subnet 192.168.1.x with a Class C subnet as well. The VPN setup and configuration have been performed prior to the recording of this video, as it is out of specification of this video series. We can, however, prove the VPN connection by pinging both from the cloud system to the local network and from the Patton gateway to the local IP of the PBX. The setup process for the Patton gateway via VPN is much the same as the on-premise. First, we require the Trinity templates found at Patton's website here. They need to be downloaded and placed, in this case for FXS, in the folder location on the 3CX system, in this case Windows, in the location below. Please note that FXO and ISDN gateway variants use a different folder location. Within the FXS DECT tab on 3CX, we select Add FXS DECT here. We select Patton as the brand, and our Trinity templates can be seen below. I am using a Patton 41412JS, so in this case I would select the 2-port Trinity variant. As you can see, however, I have already set one up here. From the configuration, we require to include the MAC address, gateway hostname or IP, subnet mask, SIP port, fax transmission mode, which can be T38, G711 pass-through, or mixed modes. We also need to select our country tone set as well. We then use the provisioning link here to import the configuration into the Patton gateway, and as seen in our previous video, in the Patton gateway, all that is required is to go to System, Configuration Files, Browse, and reboot. You will then see on the interface of 3CX our two extensions for the FXS gateway are now green and registered, and in the Phones tab we can see the details regarding those extensions also. It is also necessary to configure a default network route in the Patton gateway. This is required when your network includes either routed subnets or VPN networks. This can easily be configured from the CLI of the Patton within the routing table, which can be found in the context IP by entering the following command. In this case, our local router to the Patton gateway is 192.168.1.1, which is our router that terminates the VPN tunnel. To confirm that the command has been entered successfully, I can enter show route and see it entered in the routing table here. So let's take a moment to have a short introduction into QoS in environments using VPN tunnels. Generally, QoS, or quality of service, is the practice of configuring our networks to provide good quality voice. This includes minimizing delays and interruptions to the communication stream. VPNs can present some issues in environments where bandwidth is limited or we have high call volumes. Some issues include VPNs encrypt packets, which can increase the bandwidth requirements when running IP telephony over an IPsec VPN. The links at either ends of the VPN tunnel can also cause what is known as a bottleneck. QoS can be configured to prioritize voice traffic over other traffic types which wish to use the VPN tunnel. In VoIP systems that traverse the internet, the bottleneck will typically occur at the access link. This link in some cases serves both voice and data traffic. So from our examples you can see the potential for wishing to use QoS configuration on our networks. On top of QoS, you can also change your codec types to those more designed for lossy links such as G729 or the Internet Low Bit Rate codec. Adjustments can also be made to the VPN's encryption authentication settings. Doing this has been known to reduce overhead by up to 20 to 30%. As mentioned previously, changing your voice codec types to a compressed codec can save you on bandwidth. Codecs can be also configured from 3CX. However, for those of you who require to do this manually, the following can be performed. We will make the changes to the default VoIP profile. We can see here the codec set on the default VoIP profile. As standard on the default VoIP profile, we are using the G711 codec types. Note: G711U is mostly used in the USA and G711A is used in Europe. G711 is an uncompressed codec and will offer us great voice quality. However, for this exercise we are going to change the codec type to a compressed codec to save on bandwidth. To configure this in the default VoIP profile, the following commands apply. This will remove both U and A law codecs. We will now configure the two compressed codecs ILBC and G729. If we run the show command again, we can see our two compressed codecs configured here in the default VoIP profile. We can further confirm the codecs used by either running a PCAP trace from the 3CX PBX or on the Patton gateway running the command debug SIP transport detail 5. We can see from the screen here in our SDP body are two codecs present. Please note, codec choice may change when the call traverses our SIP trunk. This can vary based on codecs supported by the provider and other elements within other call legs. Patton products do provide mechanisms to help provide seamless voice quality. Downstream QoS is one such feature. This creates a dynamic virtual bottleneck at the customer premises. Downstream QoS can throttle incoming data to ensure time-sensitive voice traffic gets through to you promptly. For more information on downstream QoS and a configuration example, see our links from the Patton website here. So, starting from a configuration prompt. Voice margin. When priority traffic is present, the smart node reduces the maximum bandwidth for incoming traffic by the specified bitrate in kilobits per second. The throttling effectively reduces the average rate of incoming data packets, which frees bandwidth for priority traffic, thus improving voice quality. Queue limit. This setting tells the smart node how many packets to queue before dropping excess data traffic. The default queue size is 16. We now go to the context IP and apply the service policy to the WAN interface. And that leads us to the conclusion of today's video on 3CX IP PBX and Patton Trinity gateways. For more information on these products, please see the below websites. I'd like to thank you for viewing.